Okay, on to the paired t-tests. Paired t-tests are also called paired samples t-test. That's not a big deal. But what is imperative in order to run a paired t-test is the sample sizes of each group has to be identical, or it wouldn't be a paired t-test. The main difference between a paired t-test and an independent t-test that I have found mathematically is that the paired t-tests, when you're doing your actual t-test statistic calculation, each group mean is divided by its own standard deviation, where an independent t-test, they use what they call a pooled sample variation. In other words, they add all the independent scores from both groups together and find that standard deviation. But again, like I said, normally you get the same results with whatever test. So first thing, paste these into a Excel spreadsheet, your favorite friend. It is a very useful tool, Excel spreadsheet, because it's a lot easier to use, and you can format your data before you import it into a SPSS. So here's the April sales and the June sales. So we're going to run the test first in Excel because we can. I'm going to pick a cell, any cell, function bar, t-test. All right, t-test. Click OK. Array 1 is going to be our April. Array 2 is June. Two-tailed test. And this time it is a paired samples t-test. Oh, close but no cigar. We have our p-value is 0.06, which is greater than 0.05. So unfortunately, at the 5% critical cutoff level of alpha, we cannot reject the null. In other words, there was no significant difference in car sales between April and June. But we're going to go ahead and repeat this in SPSS. Please hold. Okay, I opened up a new SPSS sheet. Now, that's the difference between an independent t-test and a paired samples t-test in SPSS. If you're going to use a paired sample, each group needs its own file. In other words, its own variable. So with an independent t-test, you have to make a categorical variable, but with a paired t-test, you do not. So let me try to walk you through this and hope it'll make sense. So here's April. That's going to measure just the number of sales in April. So we need to tell the computer that we're dealing with a scale number, right? Just how many cars they sold in April. Repeat it for June, right? Just a scale number. And don't like the decimals. All right, let me go to data view, and I already cut and pasted the data in here. Okay, so I'm going to skip the normality real quick. I am going to go to analyze. I'm going to go to descriptive. I'm sorry, compare means. Paired samples t-test. Kabam. So we're going to compare April, that's the first one, to June, the second one. See what kind of options we got. No. Hit OK. And let's look at see what the t-test says. Okay, 13 in each group. That's good. Correlation was not very strong whatsoever. So this might not have been the right test to run. Okay, that's basically what it's saying. And our t-test is negative 2.04. Now on the tables, without going into a lot of detail, we just take the absolute value of the t-test. We always consider it to be positive, okay, because it's a symmetrical two-tailed test. But again, the significance is greater than 0.05. So there was no significant difference between the groups here. So remember, you're going to need to take some of this information and put it into your APA formatting, like the means and the standard deviations of each group, and your t-test statistics, the degrees of freedom, and the significance. But now I'm going to go ahead and do the next problem on this same video. So please hold. Okay, so here we are back in the Excel, and I got my September and November figures up. I'm going to pick a cell, any cell. Function bar, t-test. Array 1 is column 1. You know, the more you play around with these, the better you get. So I suggest you play around with them because they're fun. Two-tailed. And again, this is a one-paired t-test. And let's click the OK button. Boom. Well, what do you know? That number is less than 0.05. So we get to reject the null hypothesis. In other words, there was a significant difference in car sales between September and November. Apparently, the cash incentives were a better motivator than a speaker. But let's repeat this in SPSS. Please hold. Okay, I'm using the same SPSS. I just changed the names of April and June to September and November, and I already cut and pasted the new data into the cells of the data view. Okay, so again, I'm just strictly going to run the t-test. I'm going to go to compare means, paired sample t-test, and let's take these out so we don't get confused. So what are we comparing? Boom, September number 1, November number 2. Remember, paired t-tests, SPSS, they need their own separate variable. Okay, and don't need any options. Let's just click OK and see what this thing says. Dun, 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 dun. So again, 13 in September, 13 in November. That was the count. Sample size per group. You got a much better correlation here. It's not the strongest in the world, but it's going to basically tell us that the t-test will be significant. So let's take a look at the t-test table. Da-da-da. There's our t. It's about 2.42. That's pretty big. Degrees of freedom 12, and our significance again is less than 0.05. So there is a significant difference between the number of cars sold in September and November. So again, it looks like the cash incentives work better. Dun-dun-dun. So again, you have to write this stuff up. Remember the means and the standard deviations, the t-scores, the degrees of freedom, and the significance level. But let me check that last question. Please hold. So which type of test would you do when you're comparing like sales over time, anything over time where everybody is in the same group but the timing is different? This would be used, what you would use here would be the repeated measures one-way ANOVA. Okay, got it? Repeated measures one-way ANOVA. And question number 4 is there's a lot of stuff that could be affecting the way cars are sold, usually money, you know. So sometimes around Christmas, money is looser. So people go out and buy more cars. And then like in April, people are paying taxes. So, you know, the extra money is not there. So any one of those could be what we call a covariate or a lurking variable or a confound variable. Something else that is influencing the outcome of this test. But that's it.